Good day, ladies and gentlemen, boys and girls, friends and neighbors. Today we're going to start in Unit 1, Lesson 1, the Cartesian coordinate system. And for a pre-calculus class, you would think that this would be an elementary lesson, something that we would have gone over in Algebra 1. Well, in fact, we have been going over the Cartesian coordinate system for quite some time in all of your pre-algebra out and both of your Algebra 1 and Algebra 2 classes, and also in some analytical geometry. The reason why this lesson is so important is these topics that we're going to talk about here in a little bit. This is an important lesson because these topics we will revisit them in our study of calculus. And this is pre-calculus, so we're getting ready for calculus. So let's jump right in. Cartesian coordinate system is a rectangular coordinate system. This is going to be important, which is the coordinate plane that we will use to assist us in our study of functions of real numbers. Many times we will use this system to graph equations of two variables that do not represent functions. But for most of our study, the two variable equations can be represented implicitly and explicitly as functions. Okay, let's see here. The system always contains a horizontal axis, more commonly referred to as the x-axis. And we know that, and we're going to just write that down here. But you will hear me often in the course, during this course, refer to the x-axis as the horizontal axis. It's the axis that's horizontal by definition. And the vertical axis, the axis that's vertical, these axes are more commonly referred to as the y-axis. This is certainly not new. We can and we will label these axes with many different variables as the course progresses. These axes are divided into 4 quadrants. We know this, so let's just see what kind of, let's make sure that we review how we label the quadrants. This is going to be quadrant 1. This is going to be quadrant 2, quadrant 3, and quadrant 4. This will be important in our study of trigonometry because, as you notice, the quadrants are labeled counterclockwise. Alrighty, so let's go into our first example. Consider the points x sub 1, y sub 1, and b x sub 2, y sub 2. What determines if A is in quadrant 2? Well, if A is over here in quadrant 2, let's for a brief moment and just put A over there in quadrant 2. What do we know? Well, we know that x sub 1 is going to have to be less than 0, and y sub 1 is going to have to be greater than 0. So the x is going to be negative over here, and the y is positive. And this is just a mathematical way to say x is negative, y is positive. What determines if B is in quadrant 4? If B is in quadrant 4, what do we know? We know that x, let's assume that B is down here in quadrant 4 somewhere. We know that x sub 2 is going to be greater than 0, and we know that y sub 2 is going to be less than 0. So just to review points in the quadrant system. We're going to talk about this very important topic in calculus, this thing of horizontal distance. And we're going to always assume, just to make it easy, and we're going to try to make this as easy as possible, we're going to assume that this x sub 2 is going to be greater than x sub 1. The horizontal distance from x sub 1 to x sub 2 is defined to be x sub 2 minus x sub 1. So another way to write this is the rightmost x point, right minus left. This will pop up in calculus a lot. Right minus left. This is right, this is left. If I'm greater than, that says that x sub 2 is right of x sub 1. So this is right minus left, and we're going to put a couple stars on this. This is important, right minus left, very important. And now we're always going to assume that y sub 2 is greater than y sub 1. If y sub 2 is greater than y sub 1, the vertical distance from y sub 2 to y sub 1 is defined to be y sub 2 minus y sub 1. And the way we want to write this is going to be top minus bottom. And that is also terminology that we're going to use in calculus quite a lot, top minus bottom. So we'll put a couple little stars here. Okay. The other thing that you need to realize in life, in physics, in math, distance is always positive. So distance is always positive. Therefore, horizontal distance is always positive as well as vertical distance. All right, so let's see here. Let's do an example. Given A is 5, 9, and B is 2, 13, we're just going to estimate where they are. We're going to let A be right here, and this is going to be A point, 5, 9. And I'm going to give I want the analytical and graphical solution, and I want the vertical and horizontal distance, and I will graphically explain what these guys mean. And then if I have C, or B, pardon me, is going to be 213. He's going to be up here. 213. And so I want the vertical distance from those. And I'm going to see if I can't get a lighter line in here. Let's do this. You would think that that is the shortest distance from A to B. But if I want the vertical distance, I have to go along a vertical line. And the vertical line, by definition, are lines that are parallel to the y-axis. And let's do a horizontal line. We're going to do a horizontal line in this funky teal color. There you go. And all I'm going to do is change my A right here to match up with the, change my B. So this blue line, or teal, if you will, this distance here, that's called the horizontal distance, because it's along a horizontal. And horizontal lines, by definition, are lines parallel to the x-axis. This is the horizontal distance. And this right here is the vertical distance. And I'm going to abbreviate distance here. And so I want that. So what I'm going to do, and I'm going to do this a lot, I'm going to come up with this reference point. And this reference point, and I think in the other examples, we're just going to, for giggles, call that D. So think about what the coordinates of D would be. So D is going to have the same X as B, and it's going to have the same Y as A. And keep in mind, this is totally out of perspective, but that's okay. It's not to scale, if you will. So this vertical distance, then, is going to be this right minus this left, so the horizontal distance. So the horizontal distance here, I'm going to abbreviate that, horizontal distance, is going to be right, which is 5, minus 2 is equal to 3. And you should be thinking, Mr. Strassel, why are you going about this such a long way? Well, it's because if I know where we are going with calculus, with this vertical and horizontal distance stuff. So the vertical distance is going to be top minus bottom. So I ask you to bear with me on this. This is going to be important. So this is your y that's above this y. So this vertical distance, and we know, if I just ask you what that distance was, you would know. But how we want to write it in calculus is 3 minus 9, which just so happens to be 4. All right, so we got vertical and horizontal distance. Horizontal distance, right minus left. Right minus left. Vertical distance is top minus bottom. All right, page 2. And so consider the points on the coordinate plane x sub 1, y sub 1, b, x sub 2, y sub 2. The distance from A to B, denoted by AB, is given by the following. Well, that's just another form of the Pythagorean theorem. And we're just going to, I'm going to put A up here. Again, just for an example. A actually could be anywhere, and I'll show you why. That's x sub 1, y sub 1. And B, we're just going to get wild and put B down here. X sub 2, y sub 2. And what we want here now is we want the distance from A to B. So really, we want this distance here. Let's label that in the pretty blue color. This is the distance we want. And we've done this, and we did this in geometry. In fact, the IXLs that go along with this particular lesson are from geometry. But that's okay. So in order to find this, I'm going to use the Pythagorean theorem, but I need to look at these horizontal and vertical distances. Jump. So I'm going to let this be the vertical distance. If I can get this about right. And I'm going to let this rascal, do a nice color green, be the horizontal distance. So I see that my lines are a bit off. You're just going to have to bear with me. That one isn't really horizontal. But oh well, you're just going to have to do the best you can. This is going to be a right, because by definition, vertical lines and horizontal lines always intersect at right angles. That's by definition. That's not just random out there. So again, what do we want to do here? We want to come up with this point that's going to help us find the horizontal and vertical distances. Well, what point is that going to be? It's going to be this guy right here. And it's going to have the same x as A, because it's going to be on that vertical, so it's going to have the same x, and it's going to have the same y over here. And so now the first thing we're going to do is we're going to find this horizontal distance, because this distance AB by the Pythagorean theorem is going to be AB squared. Is going to be the horizontal distance squared plus the vertical distance squared. So what is the horizontal distance? The horizontal distance is going to be x sub 2 minus x sub 1. Square that baby. Plus the vertical distance is going to be top minus bottom. Y sub 1 minus y sub 2 squared. And that's what AB squared is going to be. And therefore A, that's where we come up with this distance. AB then, it's going to be the square root of this guy right here. But, oh look, these don't match up. And what we need to know is if I take y sub 1 minus y sub 2 square, it doesn't matter if who's bigger. Now, the vertical distance is y sub 2 minus, the vertical distance is y sub 1 minus y sub 2, but that's the same as y sub 2 minus y sub 1 once you square it. So what I'm going to do for my distance formula is I'm just going to write it x sub 2 minus x sub 1 squared plus y sub 2 minus y sub 1 squared. And that's the distance formula. And it's just another form of the Pythagorean theorem. Here I have this horizontal distance. I'm going to call it h. And I have this vertical distance. I'm going to call it v. And I have this distance right here from A to B. We can call this, oh, we'll just call it, we can just call it n, if you will. And by the Pythagorean theorem, we know that v squared plus h squared is going to be n squared. That's the Pythagorean theorem. And this distance formula, and this is the formula that we're going to use in our assignment and that we need to know, is just a form of the Pythagorean theorem. And we also need to know that if I'm talking about a number being squared. Y sub 2 minus y sub 1 here is positive because I want the vertical distance to always be positive. But if I take y sub 2 minus y sub 1 and square it, it's still going to be the same positive output. All right, so we're going to use the Pythagorean theorem here, and we're going to find the distance 5, 9 is from 12, 13. All right, so let's go to here, and that was, I think, the same points we did before. We're going to go 5, 9. We're just going to do that thing out of scale again, 5, 9. And we're going to come up here and do 2, 13. And I want the distance A is from B, and this point is A. And this point is B. So this is the distance that I want right here. And so I will give a graphical solution. The graphical solution of that particular distance, I have to do a right triangle here. Here's my right triangle. It's going to be that, and that distance AB is going to be AB squared, but by the Pythagorean theorem. Well, what point would we like to use here? What point do we need? We really need this point. Again, we need this point D. And what is that point? That point is 2, comma, same X, same Y, 9. 2, comma, 9. So this guy is going to be, the horizontal distance is going to be 5 minus 2 squared plus vertical distance 13 minus 9, 13 minus 9 squared. And so then AB is going to be the square root of 3 squared plus 4 squared. And you know that this is should be a very common Pythagorean triple. AB is equal to 5. All right, one other thing that we're going to talk about today, one quick thing that we're going to talk about, and we're not really going to develop this formula. I'm just going to throw it out there. This is another very straightforward formula from geometry that's kind of useful. We're going to throw it out there. It's not going to be as useful as horizontal or vertical distance, but consider the points on the coordinate plane x sub 1, y sub 1, and again x sub 2, y sub 2. Recall the midpoint formula. So the midpoint formula is just the average of the x points, comma, the average of the y points. So, and I want the analytical and graphical solution is going to be very easy. The analytical, so I want the midpoint. What is the midpoint of AB? The midpoint of AB is going to be the average of the x's. So it's going to be 5 plus 2, taking the x coordinates divided by 2, comma, the average of the y, which is going to be 9 plus 13 over 2. And what is that point? This is going to be 7 halves. Let me scoot down here a little bit. This is going to be 14 divided by 2, or 22 divided by 2, which is 11. So this midpoint then is going to be 3.5, comma, 11. What we want to do graphically is just we want to make sure that this is about where it should be if I were going to do this on the graph. So we're going to, again, plot 5, 9. I'm going to plot, I want to continue to plot it in red. This is going to be A, which is going to be 5, 9. Keep in mind this is 5, and we're going to come out here at 2, 13. A little bit farther up this time, 2, 13. And I want the midpoint. Well, the midpoint is going to be, and it's hard to see out of scale. It would be nice if everything was in scale, but it's not. So that's about the midpoint. We know we can actually, we know we can plot the midpoint. But hey, what is this output? Oh, the y there is about 11. That's about the middle of 13 and 9. Yes, it is. So if I were going to go straight up 13 to 9, the midpoint would indeed be 11. And what is this midpoint? What's the midpoint between 2 and 5. How do you, oh, that is 3.5. So this is simply the graphical solution of that right there. It's just more of a graphical representation, not a graphical solution. More of just a graphical representation of the midpoint. Okay, so we do have, there is a nice activity that we may make another video out of that. Make sure that when you do the activity, I'm going to ask you to try the activity on your own. And when you do the activity, just make sure that you see the graphical solution. I want to see the graphical. This is the assignment. That's not the activity. I think this is also, here's the activity right here. So make sure that you actually show the points and show the horizontal and vertical distances. Use the Pythagorean theorem to find the distance A, B, and then I think there's a couple exercises. All right, so back here, make sure that you've taken good notes. And we will call it a day.